go ahead and start. Hello, my name is Marko Rodriguez. I'm working on a project called mm-ADT. I come from the lineage of the Tinkerpop project, Apache Tinkerpop project. I was focused on graph databases. This is a project that's focused on all database systems, all query language systems, and all different types of processors. We'll talk about what that means. And it's also an economic machine. So we're trying to figure out how to fund open source developers given the situation we are now in the Amazon world as it is, the AWS world. So let's first do a history lesson to see why this is where we are and why mm-ADT is coming to be. So let's go back to 2012. In 2012, the Mayan calendar predicted the end of the world. But what we really saw was the OSS community predicts the golden age of data technologies. This was like the beginning of the Hadoops and the Sparks and the Cassandras and the Tinkerpops and the, all these technologies that Apache was just growing successfully with. So let's give a couple examples, and I'll be using these technologies throughout the talk. There's a lot more than this, but just so all my examples work cohesively, this is the 5 technologies that I chose. So MongoDB was creating something called a document database. Apache Tinkerpop was focused on graph database interoperability. Cassandra is a wide column store. Spark is a processor, so it's not a storage engine, but a processor, and it's particularly oriented to overlap type of processing. And then Elasticsearch is an index store, storing indices across the cluster. And contrary to popular understanding, I believe, is that open source software, while it's free for the user, someone has to pay that cost. And ultimately, the people who pay that cost have to pay it by doing research and development. And in order for them to provide this software free to the world, what a lot of our young innovators did at this time, these are back in the 2012 era, developers, late 20s, early 30s, they created small companies around their technology in order to fund themselves so they could provide the world free software. And so you saw this, you saw 10gen creating MongoDB, Aurelius, which was my company, was doing Apache Tinkerpop, DataStax was doing Apache Cassandra, Databricks, Apache Spark, and Elastic was doing Elasticsearch. And it was a really cool environment because we weren't experts in everything. So we saw a lot of collaboration, and this is what the Apache 2 license allows us to do. It allows us to make our software free, and if everyone's making their software free, we can piecemeal each other's software together to make services for our customers, for us to have revenue streams, so that we can continue to fund the development of the software. So we saw DataStax, while they developed Cassandra, they use Spark for their OLAP processing, and they use Elasticsearch for their indexing. Aurelius was a graph database company, and we were focused on developing Titan. I don't know if anyone remembers Titan. And we were creating Apache Tinkerpop. And Titan is based upon storing its data using Cassandra. We see other things like this. We see Databricks was developing Spark, but they did it via Hadoop, so they can ride on the back of Hadoop in many respects, HDFS as their storage system. And they've gone far since then, but again, it was 2012, what were we doing? And Elastic was creating Elasticsearch, and Elasticsearch uses Lucene. Basically, Elasticsearch is distributed Lucene. And so I call this the NoSQL Summer of Love. In 2012, a whole bunch of different companies were creating a bunch of technologies that we all related together. No one stepped on each other's feet. DataStax was the distributed storage system. No one was going out there and trying to make wide column storage. None of these other companies. Everyone was using each other's technologies, but keeping within their spheres of influence, so as to say. And I like this slide a lot because I consider we created the modern world's current data infrastructure. I compare us to the 1930s post-depression era generation where they were building bridges, dams, and interstates. But if you think about how the bits and bytes move around the world, it's because of the Apache software technology that has been developed over the last decade. And I think we did something really good for this world. Primarily by making our software freely available, many institutions that would not otherwise be thinking of using cutting-edge technology were able just to use cutting-edge technology. It was free. It was free to use, and that's great. Everyone could advance their domain. And then the parasites. And this is where we sit today. And I fade this out because, while Microsoft has been doing some kind of, they're cloning Mongo and they're exposing Cassandra APIs and all that, they're not so bad. I mean, they're heavy research and they make all that stuff public. IBM, we'll see what they've been up to, but Amazon. Amazon is the nefarious party in this talk. So let's talk about what Amazon's all about. There's good use of open source, and there's bad use of open source, and there's the ugly use of open source. So let's talk about the good. In 2015, Amazon announced that they're using Tinkerpop to do all their internal logistics routing. I don't quite understand what their system was about, particulars, but just how they're routing packages throughout the world. And this was really cool. So we were very excited about this. Amazon gets free software for their shipping logistics. Tinkerpop gets tested at scale on a world-class problem. And DataStax, who at that time were the primary developers of Apache Tinkerpop, they had just acquired our company, is able to point their customers to a success story. Look at what Amazon's doing. If Amazon can be using this technology, guess what? Your company's going to be able to use this technology successfully. This is the bad. MongoDB's technology starts to become subsumed by Amazon's DocumentDB through compatibility APIs. Apache Tinkerpop is seen in Neptune. Cassandra, they just released, Amazon just released a hosted managed Apache Cassandra as a service, and Spark. The EMR has Spark, Hadoop, HBase, Presto, Hive, and other big data frameworks, all within this service. And then the Elasticsearch story, I don't know if you guys know Elasticsearch story, but Elastic, even to today, is still fighting with Amazon for stealing the name of their company. So it's a pretty nasty situation. And this is the ugly situation. While we talk about, well, this is open source, everyone can use open source, who cares? It's freely available, it's great, but what they're doing is they're cutting off the revenue streams that allow us to build this technology. And so basically they have free workers. Amazon has acquired all these OSS companies who still are producing this software because people depend on it, but now 10gen works for Amazon. Aurelius at the time, now with DataStax, works for Amazon. DataStax works for Amazon. Databricks works for Amazon. Elastic works for Amazon. And this is a nasty situation that we've gotten ourselves into with the Apache 2 license. And Amazon's kind of like retort to this is, well, you know, we all contribute. This is open source projects. It's a community. And I'm going to distill the lie. There is no community in open source. There's a couple Rambos who do all the work, and that is it. And so let's look at the statistics and see what Amazon actually contributes. Let's look at MongoDB. If you look at MongoDB's commit logs, you see who's doing the work on MongoDB. ERH and Dwight. These guys have written 1 million lines of code to this project, or commits of line. I don't know, it could be documentation. But anyway, lines of work, 6,000 commits. These are the heroes of MongoDB. Do they work for Amazon? No, they don't work for Amazon. There's the third and fourth. You'll notice this trend. While this guy is doing 900,000 lines of code, A Staple and Redbeard, they're doing 100,000, 200,000 lines of code. You'll see this thing constantly tapering off. There's only a few guys who are doing most of the work. If we look at Tinkerpop, Stephen Millett, he's done 1 million lines of code. I've done 900,000 lines of code. And then it drops off significantly, 158,000 lines of code. And then Robert Dale, 3,000 lines of code. Do they work for Amazon? No, they do not work for Amazon. Let's look at Cassandra. Who does all the code for Cassandra? Look at Jay Bellis. This is Jonathan Ellis, who just gave the talk previous to this. He's done 500,000 lines of code, and again, it starts to cut off. So it's DataStax, and even the Oracle guy, why he's number 4, 18,000 lines of code. Is Amazon involved in any of that? No. Spark, what are we doing with Spark? Look at Mateus, he's doing 1.6 million lines of code. That's a crazy amount of code. And all these guys are Databricks guys. Elasticsearch, all Elasticsearch guys at 1.4 million lines of code, 1.3 million lines of code, and then it starts to taper off. Again, all working for Elastic. And so this is what you see in all collective endeavors, from Wikipedia to open source software. There's a few people who do all the work, and most of the people do very little of the work. So the MongoDB guys, there's only a couple guys who've done most of the work, and this is on a log scale. And so how many commits have they done? There's hundreds of people who have done 50 commits, but the guys who have done 5,000, 2,000 commits, there's very few of them. And you see this in every project. This is called a power law distribution. The smaller the number, the more I call Rambo the project is. The more sharp, the more there's a few people doing most of the work. Every project is like this. If you look at Wikipedia, it's like this. There's very few people actually contribute to Wikipedia, but most of the people benefit from Wikipedia. What you got?
Have you done for Rust by any chance?
For who?
For Rust.
No, I got a couple more.
Actually.
Yes, so let's do a couple more though. This is interesting. So I don't know, Scylla, how do you pronounce these guys' names? Scylla? Scylla guys. They wrote a cool blog post about what happens now that Amazon has just released Cassandra's service. Cassandra likes to, or Amazon likes to brag that, oh, we'll be contributing back to Cassandra. There is no way that they're going to be able to contribute enough code to be considered a legitimate contributor to these projects. These projects are 10 years old. They're ancient projects. They've calcified. To do radical changes to these code bases is not legitimate. So their discussion of that they are part of the community, they are not part of the community. Let's honor some of our other fallen soldiers. Redis. Elastic Cache by Amazon, which is basically just cloning Redis. We look at anti-res. Look at this guy. I mean, just a monster at the code. 500,000 lines of code and just constantly coding. This guy's just a phenomenal developer. And where did he work? He does not work for Amazon. Look at this guy, Saint Stack. This is Michael Stack, right? Is his name? He has 4 million lines of code. He works for Cloudera. All the Cloudera's work is being cloned by Amazon EMR. So just look at what's happening. These guys who are writing all this code, who have these companies, are now getting their revenue streams taken away from them. And so it makes it very difficult for them to continue. And I don't even know the story behind MariaDB or what the history is, but 8 million lines of code, 9 million lines of code. This is an astronomical amount of work these guys are doing just to have their stuff wrapped by Amazon and killing off lines of revenue. It's a nasty situation. And so again, here's our distributions. It's always the same kind of lines. This is log plots. A few guys are doing all the work. And it's not like these guys are bad people. I mean, it's not like they're not doing work. I'm just saying that you got to think of who's doing the work. Is Amazon ever going to be able to get to this level to be considered legitimate contributors, legitimate partners in this effort, this open source effort that we're doing? And what I'm trying to say is no. And so we look at the Apache Software Foundation. It was awesome. It's a 20-year-old foundation. They've done great work. They've gotten software out there. They've protected all these developers legally. Phenomenal. They are not evolving with the times. As of this point right now, the president of Apache is an IBM guy. And I used to call them the IBM Software Foundation when they did this back in 2016. So this is what IBM's doing. Aurelius had Titan and Apache Tinkerpop, our open source projects that we developed. What does IBM do? They create something called IBM Graph that just wraps our stuff, puts in the cloud, diverts revenue. Do they do any work? No. They contribute nothing, they take everything. We put Apache 2, understood we put it Apache 2. There's some kind of honor code that is dropped, lost. What we were trying to do is no longer reasonable. Now the problem is Amazon. And so while Amazon will say, no, we're not stealing, we're doing everything fine, it's illegal, all the headlines point otherwise. People say they're strip mining code. Confluent is having to change their open source, the guys who create Kafka, changing their open source license so the cloud providers can't poach their software anymore. The Elastic story is just a nasty story, stuck in a legal quagmire these guys are with Amazon. It's article after article of just Amazon stealing stuff. And this is what's crazy. Their response, Andy Goodsman of Amazon, says, we are not deliberately copying open source software in order to profit from other people's labors. We're just giving the customers what they want. That's fine, giving the customers what they want, but they obviously understand that they may not be deliberately, but they're copying open source software in order to profit from other people's labor. So it's a massive company with a lot of money, and people are working for free for them. So understand that some of our best and brightest people in this world are working for free for Amazon, indirectly through this model that we set up. So it's not illegal, but just I want you to understand the situation that we are in and how money is flowing through our economy. And so this is what I see is going to happen. What are the predictions I see if we keep going? Amazon's going to continue to release products based on Apache software technology. Why not? It's cheap, it's free, they get free labor, they get the best and the brightest minds working for them for free. When they have completed their exploitation, I think they're going to start to look at the Apache Software Foundation, try and dismantle it. And they're going to get them stuck in a legal quagmire. They don't want avenues for new growth of new technologies because it's going to be too costly for them to maintain all these services. That's a lot of services that they have to maintain across AWS. And so they don't want any new technologies. I think they're going to try and get the Apache software shut down. I know the Apache software at the time when I joined the project, Apache Foundation, they had $1 million in their coffers for legal related issues. When Amazon 2 years ago announced that they were cloning everyone's software, the community got really upset. What are you doing, Amazon? You're taking off our code, and this is like not what we thought open source was all about. In order to shut up Apache, they gave them $1 million donation. Apache writes an article saying, oh, Amazon is so open source friendly. So you get this, even with $2 million, if they get stuck in a lawsuit, it's over. Apache Software Foundation is going to get hurt really bad. So we're going to have a whole bunch of open source developers using less liberal license. Innovation in our industry is going to come to a standstill, and your beloved Data Days conference will be subsumed by reInvent. Here's where it starts to get nasty. Popular open source technologies are continually being taken by Amazon. If you close source a technology, they will just clone it via APIs or just any way in which something is going to be popular. They have a massive engineering force. They have no scruples. They will just take and clone your software. That is the fact of the matter. It's happening now with, for example, how they're doing Mongo, how they're treating the Mongo situation. So small, agile data technologies that produce this technology will struggle. Majority of this data systems engineering jobs will go to Amazon. When you have a pool of engineers all stuck at one company, what prevents the company from just lowering their salaries? There's no market, there's no job market. So why don't we just start lowering their salaries? We're going to see what's going to happen at Amazon, or at Google. They're going to try and create labor unions. Labor union efforts are going to be squashed by Amazon. Employees will be stuck in these legal issues as they're suing each other, this is and that's. And ultimately, the biggest problem to everybody in this country and potentially the world, just because of just the loss of revenue, taxpayers will be left to foot the bill in the most expensive antitrust suit the US government has ever endured. So Amazon is going to be a beast that's going to be impossible to kill, and it's going to be just a nasty amount of money and just a loss for everybody, a loss for everybody. And what does that loss look like? I think that Amazon is ultimately leading to the systematic desertification of our industry. They need to make money. It's not about the technology. The technology does not matter. We're just gonna have a barren landscape. Day-to-day talks are gonna be one guy, one dude in the audience. And so I wrote this little poem. It was a tweet just to piss him off. Oh, Father, love of mine, you have built such wonderful things with all your time. In honor of your greatness, we followed behind, and now of age, we give you not what was mine. May our software make your machines sing to the heavens for all of time. And it's this notion that, we looked up to Amazon, we looked up to IBM, we looked up to Microsoft, we developed a whole bunch of software that we can run on their clouds and customers could use, and they turn around and they just eat us. And this is Jupiter eating his son. And this is the situation. It's greed, it's just unsatiable greed. It's a snowball of capital that you just cannot stop. Amazon is it's unstoppable. It's just it needs to consume capital. That's how it lives. So, in this dire picture that I've painted, and maybe a lot of you don't see it like that, that's how I've come to realize what our industry is going towards. I said, okay, so how am I going to do something for this situation? And so mm-ADT is a solution to this problem. The mm-ADT virtual machine it's a piece of technology, and we'll talk about the virtual machine, and then we're going to talk about the economic machine that follows suit. So let's talk about the technology. So we have a bunch of modern data systems, and mm-ADT classifies data systems into 3 categories. We have storage systems, we have processors, and we have languages. We're familiar with all storage systems. I don't know if you guys know Akka. It's like a message passing system. Reactive, it's a stream-based with push-based semantics query processor. Flink, distributed processor, much like Apache Spark. And then languages. We know the gremlins for graphs and GraphQL and Sparkle and XPath and SQL. Anyways, we have these classifications. What mm-ADT allows us to do is create synthetic data systems. This is the idea that I can mix and match my storage, my processor, and my language. And so the way it does this is that through these distinctions, if I have an algebra, a model in which I can represent storage systems, if I have a model in which I can represent languages, and I have a model in which I can represent processors, and then I have a model by which I can integrate those different algebras, then I can have these things communicate with each other. And so the idea is that you have a query language that'll program reactive X. In this particular example, Gremlin programs reactive X, which will read and write to Cassandra. And the idea is that we have three different kinds of representations. So storage systems, if they expose their internal representation according to our type system of bool, int, real, string, list, record, then that every storage system that we know, from wide column to graph to key value store to document store, have a nice representation with these simple data types. We can talk about date, time, and all these in blobs and binary. Before our initial push, these are the core data types that really matter for 90% of 99% of use cases of databases. And then we have something else. The next thing is, how do you model languages? So when you have a query language, what is it going to compile to? So the virtual machine has an instruction set architecture. Instruction set architecture, if you know CPUs, is opcode with a bunch of arguments. So ultimately, what we're just executing is instructions in this virtual machine. And so we have an instruction set, and that instruction set needs to be executed. And who's executing it? The processor. And the processor needs to implement the semantics of these operators. So every processor that I've mentioned that you know of that can faithfully execute these particular operations. Initial is something that just spawns a process. Map goes one-to-one. It takes something and turns into something else. A filter takes something, it'll kill it or let it keep going. A side effect is updating some data structure on the side, for example, like output, println kind of stuff. A terminal is basically taking a whole bunch of information and computing it, but not returning anything. Branching is how we do choices. This is how we do loops for repeating. Reduce is a many-to-one, like counts and sums and those kind of things. Take many things and map it down to one thing. And then barriers is how we synchronize computations in a stage-wise fashion. So it's a kind of like a synchronization mechanism. So if your processor can implement these particular operators successfully, then our instruction set from query language will be able to execute over those processors. And then what they're ultimately doing, these processors are computing over the data types of the storage system. All data systems ultimately have this. If you look at any kind of database system, they ultimately have this notion of how they're coupling their query language, their processor, and their storage system. But now we're not making that such a gobbledygook mess. We're separating out these things and we're having distinct algebras to describe how these things relate to each other. It's a very hard problem, but I got nothing else to do with my life, so let's talk a little bit more specific. So storages. Storage exposes the graph model. So I'm going to show this all in terms of graph, and it's a very reduced version of a graph, not the property graph with key value labels, just to keep everything simple. So a graph. What is a graph? It's a stream of vertices. It's 0 or more vertices. One of the cool things about the algebra I developed over the last 2 years is that we understand the notion about quantifiers play with type systems. So not only do you say that something has a type, you can say how many of that type it has. And this is quite nice. So every time you see curly braces and some kind of a mark after a star, like in regex is as many as I can get. 0 or more vertices is what a graph is. So what is a vertex then? A vertex is a record that has an ID that's an integer, and it has two other fields, an in-e and an out-e. Both of those are a stream of 0 or more edges. So once I have a vertex, I have its ID, and then I have its incoming edges and its outgoing edges. So then what's an edge? An edge is a label that has three components to its record, and it has a label that's a string, and then has an outcoming vertex and an incoming vertex. So we're talking about binary edges. And so this represents what a graph is. And now you take a language like Gremlin, and it needs to be able to write out instructions that know how to manipulate this abstract data type. And so, for example, in Gremlin, you can say, for vertex 1, give me the ID of the people it knows, or the other vertices it knows. So let's assume just people. So person 1 vertex, who does he know, and what are the ID of those vertices? Really simple query, just a one-step walk. And so what ultimately is being returned, ID is 0 or more integers, because vertex 1 can know 0 people, it can know a million people. So all we know is we're getting back 0 or 1 integers. And why is it an integer? Because ID is an integer in this contrived example. And so graph, so when we go to get graph, we're streaming all the vertices. I'm not talking about indices, we're talking about the primary data model. So indices and how rewrite rules work for optimization, I'm not going to discuss in this talk. I have a talk I gave at ApacheCon in September that's way more involved about how primary and secondary structures are leveraged so you can do various optimizations. But just we'll talk everything in terms of serial scans, because you compile your bytecode assuming serial scans, and then later on it gets rewritten. So as a serial scan, I take a graph. What is a graph? It's a stream of vertices. So I'm streaming all the vertices out of the graph. And then I'm filtering those whose ID equals 1. So I'm finding only those vertices whose ID equals 1. And then for all those, I'm getting their outgoing edges, which is a stream of edges. So then I'm getting all those edges. Of those edges that are outgoing from vertex 1, give me the ones whose labels are no's. And so it's another filter operation, then I get the incoming vertex, and then I get the ID. So it's just serial scans of all this data. Ultimately, this is an index hit. This can be an index hit depending upon certain optimizations in graph databases. This is called a denormalization. There's a whole bunch of optimizations that can be rewritten here that's very vendor dependent. But at the abstract level, how the language understands what's going on, it interprets it all as serial scans. And so then the processor, once I have this instructions written out, it needs to get sent for the processor for execution. So the processor then is having its initial, which is spawning all these vertices, and then it's filtering to those things that have a certain ID, then it's mapping to the outgoing edges, then it's filtering again to those things that know, then it's mapping to the incoming vertex, and then it's mapping to the ID. So this is how the representation, the graph database exposes itself. This is how a graph language compiles to an instruction set that's executed by a processor, and that's the loop. And that's how these things relate to each other. And so mm-ADT is all about creating models in terms of other models. And the idea is that we're going to have standardized models by mm-ADT. So we're going to publish these schemas. Let me go back a slide. This kind of stuff right here, this graph schema, we're going to have a property graph schema, so PG. And that allows us to say what a property graph is. How do you model a property graph in mm-ADT? And so all the property graph vendors, for example, anyone that's Tinkerpop, will be able to just expose a property graph representation in the mm-ADT model. We'll do key value, relational, wide column, RDF, and documents. So storage providers expose the system via these models, and they can expose multiple. So a storage provider might have a wide column, for example, Cassandra, but they can also do a graph. So they can expose multiple representations, encodings of data inside their database. And then ultimately the language providers, so you could be a key value store language, you could be a document language like Mongo's language, will then be able to compile to work against these particular models. What's really cool, oh, I took out that slide, unfortunately. Well, I'll show you this and I'll show you how something else happens. So then you ask, okay, well, so there's schemas. Users have schemas. Yes, I know there's vertices and edges, but people don't have to talk in terms of vertices and edges. There's going to be people, and there's going to be links, friendship links between people. So how do we model that? Again, it's just another model. So we have a social model where a person is a record that has a social security number that's an int, and it has a friend label that's a stream of persons. So just think of a social graph, friendship social graph, where the IDs are social security numbers. This model, this user schema, can be embedded in other models. So we can go from social, relational, down to mm-ADT, social graph, mm-ADT. So here's our two schemas. And then we show how is a person understood in terms of rows. How is a person understood in terms of vertices? So this tells you how to do the data transformations that get you from one representation to another representation. And the slide I took out at the last minute is that I can say, how do I model a graph inside of a relational model? So I could have gone graph and then have rows. How do you understand vertices in terms of rows? So you can keep stacking these representations. So while maybe Cassandra might not expose a graph representation, if I have a mapping that takes me from a graph model to a wide column model, has nothing to do with Cassandra, I can then have all of my queries that are for graph get through this mapping to ultimately execute on a wide column store. And so this is this idea that we're just embedding representations inside other representations in order to allow this kind of universal communicativity between these different systems. So this is ultimately what I feel is like the dream machine of what Amazon would love to do. Amazon would love to have one particular virtual machine that they were just optimizing, that they can just plug and play any processors. The next big thing comes out from Apache. They don't need to expose a service that says, oh, it's Apache Spark. They just know they're going to get all the runtime benefits of running Apache Spark behind the scenes because they just can integrate it into a virtual machine of this nature. Because you don't want, Hadoop came around. People invested a whole bunch in Hadoop. And then the next thing comes out, it says Spark, so everyone dumps Spark. And the next thing's going to be Flink, and everyone's going to dump Spark. And so it's just, we're just going to keep going down this line of redoing technologies as things progress. But behind the facade of a single virtual machine, like behind the facade of the JVM, you have this kind of interoperability without having to cut all your ties and scrap everything. And so what is the economic machine? So the mm-ADT virtual machine is a universal integrator for technology to our industry. So these are all the processors, languages, and storage systems. But my primary interest is making sure that OSS developers are compensated now. We're done playing the game where we're doing free labor. That's over. We need to do something different. And so what my economic machine is, how do we do a universal integration for the creators of our industry? There's 3 types of creators of our industry, and this is their plight. We have the independent open source developer. I've talked some super soft stories. Independent open source developers, they don't want to work for a company. They don't want to make a company. They're just good developers. They're usually shy, introverted kind of people, hanging out at their mom's house, eating pizza. They just like to code. All they want to do is code. Let them code, but unfortunately what happens is as their open source project becomes more popular, paradoxically, as their project becomes more successful, it can lead to financial ruin and burnout. And I talked to a girl who's working on a JS framework, and I'm not really familiar with the JavaScript scene, and she says she has to max out her credit cards to get to conferences because the companies that use her technology say, well, you need to be at this conference because you need to discuss these things because my developers are going to be there. She doesn't have it in her to say, well, you need to pay for me. It's not her spirit. And so, okay, I'll be there. Maxing out credit cards, she's in super debt so she can help these companies continue making profits. It's nasty. It's just it. And so then you get these guys who say, fine, well, I'm going to be an entrepreneurial developer. I'm going to be a guy who knows how to tell these companies, well, no, you're going to pay me some money. But the problem with these guys is they create open core technologies, and this is what we saw for the last 10 years, last decade, is everything's open source, so your core is open source, and then you build services around that. The problem is, and we see with Amazon, that because their core product is fully licensed, competing firms don't have to pay for any of the research or development. They just grab their stuff, say, oh, cool, you put a little couple visualizations, we'll throw a little couple visualizations too, and now we have a competing product. We'll drop the price because we didn't have to do research and development. So these guys are getting hit. And then you have the corporate open source developer. And so this is when someone like Amazon will hire a guy to work on, for example, Apache Tinkerpop. And we see this with Apache Tinkerpop, is that they get told what they need to contribute back to the community and what they don't. And so they know if there's a certain bug in Apache Tinkerpop that everyone's struggling with and they fix, they're not going to commit that back because they're going to try and hold their competitors off as long as possible. And so we have these open source developers that are these like kind of corporate quagmires where they can't really do what they want to do because they're beholden to these corporate entities. So these are all kind of like these are the situation open source developers are in, and it's because we are thinking about it wrong. I believe OSS developers, the top OSS developers, the guys who create the Apache software that you know and love, they're not employees. I consider them artists. They don't need employers. They need agents. They don't want to manage people. They want to mentor people. They want the younger guys who are good to hang out with them, and they'll mentor them and teach them what's going on. But they're not managers. They don't want investment. No one wants VC funding. I don't want VC funding. I don't want your money. I don't want your debt. But it'd be awesome if you patronize me, meaning you provide patron in the sense of like an art patron, not patronize me as a little boy. And so ultimately, they need to be financially just compensated for their work. So we need an infrastructure that gives them money without having to get themselves in these weird situations that they don't want to be in. And some people, and arguably some people do very well in these situations, but it's coming to a head for most of our developers. And so what I'm trying to do with mm-ADT, it's under my company Redux, and it's a no-growth company. I'm not trying to build a company to make money. I'm trying to build an infrastructure so that we can keep going with what we were doing with the 1930s style of building all the infrastructure for our world. And so I'm thinking, how does Etsy kind of Apache work? And so I call Redux a non-growth company in the sense that we are not looking for money. We're not. All we're trying to do is create a network of developers. And so what are these developers? So you can have a group of developers who are creating something, for example, a connector to mm-ADT for Cassandra, one for Apache, one for GraphQL. What Apache had taught us, and what we all do very well, is that Apache developers know how to design software, we know how to write software, we know how to document software, we know how to maintain software, we know how to promote software. We are value-creating machines. We know how to handle mailing lists. We do everything that the company knows how to do, but we're just a few people. And arguably some of the best software in the world is written by these really small teams of people who don't have managers, who don't have corporate overlords. We can just do good software. So if we're doing good software, just give me the money. I don't want to deal with any of the corporation stuff associated with that. And so one of the things that is different from the Apache model is pricing. So when a team gets together to build a particular component for the mm-ADT VM, they decide what the cost for licensing is. They say, we feel our work is this, and let market prices dictate from there. And so the idea then is that you have these small groups of people. So let's say a couple Cassandra guys pull off and they say, you know, I'm going to build a connector for Cassandra. And 3 guys, and they do the connection, Spark people and some GraphQL people. And so they design, how are we going to model this in mm-ADT? How are we going to do the wide column store according to the semantics exposed by mm-ADT? Same for Spark, same for GraphQL. So once they have their design, they implement. They develop that connector. Once that connector exists, it's up to Microcyber RoboCorp, a potential customer, that says, you know what, like, I really want Cassandra with GraphQL over Spark. That's what we really need for our particular, we need all that processing. We love GraphQL. It's a very simple JSON-based type of query language that our developers know how to use, and we want the scalability of Cassandra. So they compose that. When they compose that, that creates a cost. And that cost gets put onto Redux, it gets sent to Redux, and then Redux just distributes the money back to these groups of people. So the idea is that we can do software as a service where we can make synthetic data systems, we can expose them, companies can use them based on their usage statistics with that particular pieces of software. We know exactly how much their GraphQL service is being hit, how much the Spark aspects being hit, and then the money that we're getting for those, we just route back to the developers. And so the cycle kind of goes like that. And that is what we are working on right now, is how to do this, but what's the legal mechanisms to do this? What's the best way to do this? Is this SaaS? Is this just licensing directly? What is just the business aspects of creating something like this so that the people who create these particular technologies can get some funding and hopefully not have to struggle as we are seeing now. And that's my talk. Thank you.